Hey, what's up, guys? Chung here again. So this time, I'd like to talk about this problem, LeetCode problem 198, house robber, and it's labeled as easy. I think it's kind of easy, between easy and medium, because this will be using because we'll be using a dynamic programming idea here. Even though it's a 1D dynamic programming, but it's still a DP problem. So I think it should be like, I think between easy and medium. Anyway, let's take a look. Okay, you're given an array, right? So basically each array is a house, right? Each element in the array is a house. The robber can rob any of the house, but only with only one constraint. Only one constraint is that the robber cannot rob two house that 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 it's adjacent to each other. Basically, if he robs number one, then he can only rob two, right? And then same thing if he robs two, and then he can only rob one. And so the most intuitive way will be using a DP, right? So let's just do it. It shouldn't take too much time here. Let's do a n here, right? And length nems, right? I'll just do a regular DP here. So in this case, the DPI means until the i's house from starting to I, what is the maximum money we can get until that position, right? So that's DP. I'm gonna initialize at the beginning. We initialize everything to be zero, right? And the length will be. I'll just put it n here. So and then for I I in range n, right? So what do we do here? So basically, the idea here is that when we see a new house here, we only have two options here. We either rob that house or we don't, right? So let's say we rob current. So if we rob the current, then at least we can get the current house money, right? Plus what? Plus, let's say if we rob three, then plus whatever house we can get from starting from this I minus 2, right? Let's say here if we rob 3, right? If we rob 3 here, then uh we also need to add everything we can rob until the 7 here, right? So that's gonna be the DP, right? What, I minus 2, right? But since we only initialize this with n here, we're gonna do a range check, right? If I is greater than 1, right? Because we don't want to have an active index, right? Else what? Else we simply put 0, right? And then the second option will be not rob, right? We don't rob the current, right? Then if we don't rob the current, then we can initialize. We can get I minus 1, right? Basically here, same thing. If we don't rob 3 here, right? Then we're assuming that 9 was robbed, right? So here we don't rob 3, 9 was robbed, and then the next we can rob 1. But since we're at position 3 here, if we're not robbing it, then all the money we have robbed if by not robbing the current will be DPI minus 1, which will be 9, right? Same thing here. We do a if I is greater than 0, right? Same thing for the range check, right? And then in the end, we just do a simple comparison, right? We do a max from those two, right? Current and not rob current, right? That's and then we just return the DP n minus 1, right? Since it's a n n length, and the dp is this list is 0 based, right? That should do it. Uh, let's see. What did we do wrong here? Oh, yeah. So if we have if else here, you know, don't forget to always use like a parenthesis. Otherwise, it will like do something, then do a weird calculation here, because we want to uh, uh, in encapsulate this thing in the parentheses. Yeah. Okay. Uh, sure. Yeah. Yeah. Since we're returning this n minus one, yeah, we should. I think it's we should like initialize with n plus one, right? In that case, when we return this like n minus one, we will be making sure we still have one element left in here, right? In case there's nothing here, or we can just simply do a sanity check here. I'll just do a sanity check here. If not nums, right? I'll just return a zero here. Cool. I think it works, right? And yeah, but and this, as you can see, the time complexity for this problem is O n, and the space complexity is also O n, right? So since we only need two two values from previous calculations here, instead of using an array to store all the previous result, we can just have like two variables every time we update those two variables, and then we can just improve this code into from O n times space complexity to O1 to a constant, right? How, right? Same here, 27931, right? So for example, same thing. So when we process three here, right? All we need is the like what we discussed. We need the maximum values from either from this position or from this position, right? Because that's how we do this. We wrap current. If we wrap current, then we need the maximum value from 7. If we don't wrap 3, then we need the maximum value from 9, right? And then once 3 is finished, right? And then we have the current max value of 3 here, right? Right. So we have 3 here. So the current value, once we calculate everything, right? We have the current max value of 3, right? And then when we move to 1, right? See, all we need is 3 and 9, right? Basically, after we how can we name this one, right? So that's the sum, the sum for rob the current one, and this is the sum to not rob the current house, right? So then we can improve this thing to not using a DP, right? Instead, we just use I'll name it max sum rob current, right? And max sum not rob current. Okay. So every time, right? So every time when we see a new number here, since at this moment we don't need the index, let's just use this one here. So at this moment, when we see this one, right? What do we do? So the max sum, right? Rob current, right? And what's the current, right? What's the maximum current? It's the maximum of the of this maximum not Rob, okay, no, Rob current plus, right, plus the num, right, and the maximum sum not Rob current, right? And then here, so once this is done, right, the uh, and the value of this one will become the not sum, right? So not sum current will become the sum, right? Because once we use the previous two sums to calculate this one, for the next values, the current sum, right? That's the maximum of current sum. The current sum will become will be the not Rob sum for the previous one. Sorry. So okay. So at the moment, so when we add three, right? The and we use the previous like we use the maximum sum Rob current plus the number and also the not robbed sum to calculate at our current result, right? And once we done that, this will become the not robbed current for the next one, right? So that means we need to uh, set this one to the rob to this one, and then for the current one, right? The current one will be the value from here, right? So once this is done, right? The current one is gonna be from this value, but since we already set this one, we have to like have a temp sum here before using before like assigning update this value. So in the end, we just do this, right? And then so in the end here, we just do return this thing here, maximum sum current, right? Uh, Something wrong here. Let's see. Uh, Sorry, I think I should return this one, not Rob current. Yeah, so I know this is like a little bit confusing. So basically, okay, let me try to go over this one more time with this O1 solution, right? So every time, right, let's say when we calculate 3 here, right, we use the previous, like, we use this one, the one I call it uh, Rob current maximum sum Rob current. Rob current plus this num, right? And then the maximum sum not Rob current to calculate a biggest number, basically calculate the maximum number for this for the current position, right? And then once we calculate that, we'll be assigned instead of assigning back to the current, we'll be assigned back to this maximum sum, not Rob current, because the for the next value 1, this sum will become his not Rob current sum, right? And our current our our current not oh my god, this not Rob current variable will become the current for 1. Yeah, maybe the naming here is a bit confusing, but I'm trying to use a more intuitive variables here. You know, I think you guys get that what I'm trying to say, right? So once you calculate this one, the meaning of this two will be reversed, right? For the next one. That's why we're doing this kind of a swap thing. And in the end, we just return the not robbed current because that's always the latest uh, maximum sum for the current position, right? And okay, I think that's it. That's it for this problem. Yeah, thank you so much for watching. Yeah, and I hope you guys enjoy it. All right, see ya.